I'm very, very happy to be here amongst all of the great golfers, amongst all of developers that have the ability to change the world, because as developers we have the ability to change the world. The world has changed. And yes, these trends keep on growing. The software gave us, as humans, the capability to enhance the world. And the current goal of the software is to predict the stuff. Given Y, I want to predict X, or given X, I want to predict Y. And this is a typical case for machine learning. So as developers, we may want to use machine learning, but the ecosystem is hard. Mastering machine learning is hard. TensorFlow, backpropagation, equations. And this should not exclude us from this revolution. We should use the machine learning like any arbitrary library. We feed it some input and get the output regardless of the wiring inside the model. Let's take an illustration. Imagine this is a neural network, and a neural network is just a bunch of equations, a mathematical model, with associated values. The goal is to find the right equation and the right values for a given use case to get the most accurate prediction of whatever input. We see here that it is not linked to the execution engine, and it should not be linked to the execution engine. The value is the runtime, not the execution. So, we could imagine we can get an abstraction of this neural network, describe it in a language, an open language. We could use the superpower of machine learning and the power of our favorite language. Such a format exists. It's called ONNX. It has been implemented by some major company in the AI world. And what about Go? We could use Go as a runtime, because if we're here, we all love to program in Go. So let me introduce you to ONNX-Go. ONNX-Go is a package that facilitates the import and the usage of pre-trained ONNX model into any Go program. It relies on an execution backend, such as Gorgonia, for example. This is how it looks like. You encapsulate the model. The model is described in ONNX, in the ONNX syntax. It can be pre-trained in TensorFlow, PyTorch, or whatever, Microsoft CNTK. The model is encapsulated into an execution engine. The execution engine is abstracted with ONNX-Go, and you can use it with your regular code. So you just write a regular code the way you used to do to write it, and use the neural network as a capacity. How do you do that? You do that in 4 steps. You create an execution backend, for example, Gorgonia. Gorgonia is a good execution backend. For now, it's the only one that works, actually. You create a model. You load the definition file, which is a binary file, into the model. You set up an input. You compute and get the output. And that's it. Does it work? Right now, it's a proof of concept. And it needs love, a lot of love, of attention. But it's working. I'm able to import a pre-trained MNIST model into my Go code, write a picture, and get the result. So the concept is OK. So what now? Here is your homework. Take a look at the ONNX project. Take a look at the model zoo. It exists a lot of pre-trained models. And imagine what you, as a golfer, you can do with ONNX-Go. And if your imagination was far enough, get involved. We need some people to develop that. Nobody is a nobody. I stole this sentence from Kubernetes, but I love it. And all together, the Go community, I hope, we may be able to make programming with neural network fun again. Thank you.